Hello, my brilliant students. So today we are going to talk about operations on nth roots. So operations, adding, subtracting, multiplying, dividing, square roots, cubed roots, fourth roots, all that jazz. So why don't you pause the video and try this do now. So if you notice, you have g of x comma y comma z equals. So all this is a fancy substitution. So they're saying that your x value is 2, your y value is 4, and your z value is -3. So I'm just going to do 4, x was 2, y was 4, minus 3, x is 2, and z is -3 squared. So that's 8, that's 32, minus, that becomes a 9, minus 54, so you get -22. So the answer is A. This is a foxtrot. I don't know if you've seen this in the paper. It's got a lot of math in it, so I enjoy it. It's funny. There's a lot of the younger brother is like super into math, so there's a lot of stuff that pops up. Okay, so we are multiplying and simplifying the square root. So first we multiply. When you multiply your outsides, multiply your insides, and then simplify. Right? So 3 times 5 is 15, 6 times 8 is 48, and then we're just going to simplify. So multiply your outsides, multiply the insides, simplify. So why don't you pause and see how you do on this by yourself. So 48 is 16 times 3, right? So that is the square root of 16 is 4. The square root of 3 is just the square root of 3. And then 15 times the square root. So we end up multiplying 15 times 4, and we get 60 root 3. Next one, again, don't try to simplify first. Multiply first. It'll make your life easier. 20 times 5 is 100. And then we add exponents. 7 plus 1 is 8. Right? What's the square root of 100? 10. What's the square root of x to the 8th? X to the 4th. Because remember, a square root is to the 1/2. So this is really 8x to the 8 over 2. There's that 2 there. 8 divided by 2 is 4. Right? That's the fast way to remember it. All right, next one. So we've got 14 and 21, which gives us 294. X to the 4th, 3 plus 1, and y to the 9th. All right, so now we have to simplify. 294 is what? That's actually 49 times 6. And here's how I did it. I didn't even do this in my head. I did this in my head. Notice that there's a 7 that goes into 14 and a 7 that goes into 21. That means I have a 49 in the problem. When you take the 7 out of the 14, you're left with a 2. 7 out of 21, you're left with 3, so that's a total of 6 left over. That's how I do those, because when you're multiplying, it's really common for the perfect square to be kind of broken up into the 2 factors that are multiplying. All right, so the square root of 49 is 7. And now I have my x to the 4th, divide by 2, x squared. 9, divide by 2, but you have a decimal, right? So this is really y to the 8th times y. Y to the 8th gives us y to the 4th. And then we have a 6 left over and that extra y left over. All right, and then this last one, we're going to distribute. So the square root of 30x to the 6th, y to the 3rd, plus the square root of 18, x8, y7. All right, so 30 doesn't have a perfect square in it. Whenever you're stuck on that, just make like a old school tree. Right? The prime factorization is 5, 2, and 3, so there's nothing there. If you had something like 20, right, 2 and 10, 2 and 5, you have those 2 2's that gives you your perfect square. But in this case with 30, it doesn't work. So the 30 you can't do anything to. I'm going to simplify my x to the 6th. I get x cubed on the outside. y cubed, I got 1y on the outside and 1 left over on the inside. 18 is 9 and 2, so that gives me a 3 on the outside. X to the 8th gives me x to the 4th on the outside. Y to the 7th gives me a y cubed with 1y left over. Remember our odds, we go down by 1, and we have that 1 left over on the inside. Can we add these together? No, these are not like terms. To add radicals, the radicand, the inside, has to be exactly the same. Right? This would have to be exactly the same, and the outside powers would have to be exactly the same, right? Because the square root plus a square root, like square root of 2 plus a square root of 3, those cannot combine. Those are not like terms. You could try, plug in your calculator. You get your decimal for this is not the same as a decimal for those. All right. So based on that, what do you think we're going to do in number 5? So I have my 5 root 3, my 7 root 2, minus root 3. So now here's the question. We can combine these two together because they have the same root. What do we get there? We end up with 4 root 3. You want to treat your roots like x's. So if I had 5x plus 7y minus x, 5x minus x is 4x, right? So the root 3, it's like I have 5 root 3's and I take away a root 3. I have 4 root 3's left over. And then my 7 root 2 is just chilling there. So treat them like x's. So in number 7, we can't add those, right? Because the radicands are different, the inside number. But think about what could we do here. So with multiplying, we multiply first, then simplify. Adding and subtracting is the opposite. Because we can't add unless the radicand is the same, we have to simplify first. So pause the video, you're going to simplify, and then you'll be able to add them. So 80 is 16 times 5, and 45 is 9 times 5. Notice the perfect squares are both being multiplied by the same number, a 5 and a 5. Square root of 16 is 4. 4 times 7 is 28. So we get 28 root 5. Square root of 9 is 3. 3 times 2 is 6 root 5. Now our radicand is the same, so we are allowed to add those together, and we are done. All right, if you haven't tried number 7 and 8, pause and try them. All right, so this one, we know the square root of 4, right? Square root of 4 is 2, so that's 16. Now, where does that x go? Is it 16x or 16 the square root of x? That's an exponent of a 1. You can't do anything there, so I'm going to leave my root x. And over here, right, we get 7 times 3, 21 root x. The radicands are the same, 37 root x. Done. Number 8, this one's a little harder just because 147, 363 are not necessarily something you would recognize. 147 is actually 49 times 3. And then if you're stuck, and you got that and you couldn't figure out 363, since the non-perfect square is a 3, you could try that over here. And that actually does work a lot of the time. Not every time, but most of the time. And I get 121. Okay, so we get 7, so that's a 14, right? And then what happens with my x's? I get an x. So notice I have an x on the outside, and then I have an x from the inside. And then we're left with 3x. What's x times x? X squared. So this is 14x squared root 3x. And then over here, I have that gives me an 11. So 55. X to the 5th is x to the 4th times x. So that gives me my x squared root 3x. Are these like terms? They are. So notice the radicand is the same, 3x and 3x, and then the outside has an x squared and an x squared. So because of that, we can add these, and you get 69 x squared root 3x, and that is your answer. All right. All right, so one more like this. So pause and work your way through this problem. So 50 is 25 times 2. So the square root of 25, we get 5 root 2. So that's negative 30 on the outside, a 2 on the inside. And then x cubed, right? X cubed, that's x squared times x. So we get 1x on the outside, 1x on the inside. And y to the 8th is even, so it's just y to the 4th. Plus 98 is 49 times 2. So that's 7 root 2. So 7 times 9 is 63. The x we can't do anything with, so we have that 2 on the inside. This x is stuck inside. So we have that x on the outside. And then y to the 6th is y to the 3rd, right? That gives you y cubed. But y cubed times y gives me that y to the 4th. So notice these are exactly the same again, so we're allowed to add them together. And we get 33x y to the 4th root 2x. Now, let's say you made a mistake on a quiz. Let's say you ignored that y. So you had negative 30 x y to the 4th root 2x plus 63 xy cubed root 2x. If you get that on a quiz, a lot of times students will look at that and be like, oh, I must have made a mistake. I'll just add them together. But that shows me that you don't understand like terms. So if this happens, if you make that mistake, leave it. Don't add them together. Don't try to fix your mistake without actually accurately finding your mistake. Because if you add these together and put like y to the 7th or something, even though you know it's wrong, I'm going to take points off because it makes me think you don't understand how to combine these together accurately. So if you get something that does not combine, just leave it. This right here is one mistake, probably -1 on the problem. If you add them together and do something crazy, you're losing more points. So don't make assumptions, oh, I made a mistake, let me just do this. Leave it. Don't do anything. Just leave it like that. You didn't make any mistakes at that point. You only made one mistake at that point. Don't make things worse. Okay, division. All right, so division is the same as multiplying. You divide your outsides, divide your insides. So pause the video and try these. So we've got 282 divided by 6. And that is just the square root of 47. And you are done. There's nothing you can do there. 11 square root of 45. And then what do you do to x's when you divide? We subtract. That's not x cubed, right? It's x to the 8th. And then we can simplify. 45 is 9 times 5. Square root of 9 is 3. The square root of x to the 8th is x to the 4th. And then root 5. Done. So those were the easy ones. 12 is a little harder. 13 is obnoxious. All right, so 12. Notice you can't divide the 5 into the 38, but we can divide into the x's. So I'm going to write this as root 38 x cubed over root 5. Now, remember back when we did imaginary numbers, we talked about rationalizing the denominator. So what we can do here is just multiply the top and the bottom by root 5. 38 times 5 is 190. So the square root of 190 x cubed all over 5. Now, 190 has no perfect squares in it. And you can actually tell because you multiplied 5 by 35, right? 35 doesn't have a perfect square in it. If it were a multiple of 5, it would work. If it was like 35 times 5, then you would have one. But in this case, it doesn't. So the only thing we can do now is simplify our x cubed. So bring out 1x, 190x over 5. And that is your final answer. You cannot divide that 5 into the radical. All right, so that one's not too bad. This last one's super obnoxious, though. All right, first thing I'm going to do is I'm going to simplify. So 10 and 15 can both be divided by 5. So on top, I get a 2, and on the bottom, I get a 3. Then we have our x to the third and x to the 8th. Now, if I do 3 minus 8, I get negative 5. So I don't want a negative, so I'm going to put it in the bottom. So it's x to the positive 5 on the bottom. And up top, we have y to the 7th. Now, like before, I don't want a root in the bottom, but I can't divide anymore. So we're going to rationalize. We're going to multiply by that bottom. So times 3x to the 5th, 3x to the 5th. Multiply that, and I get 6x to the 5th, y to the 7th, over 3x to the 5th. Ooh, I forgot my root. Now I'm going to simplify the inside of the top, right? So my x to the 5th, I can pull out an x squared there, and I can pull out a y cubed, root 6x5. Oops, just kidding. I pulled out an x squared, I'm left with 1x, and I'm left with 1y, over 3x to the 5th. And then the last thing I'm going to do is I can simplify my x squared and my x to the 5th. So the final answer is y cubed, root 6xy, over 3x to the 3rd. It's a little extra. Like, it doesn't need to be that intense, but, I mean, it's doable. It's just a little annoying to do is a problem. Okay, so now we are going to multiply and simplify higher roots. So, what would you do for 4 times the cubed root of negative 20 and 11 times the cubed root of 15? So pause the video and do number 14 and 15. So just like before, multiply my outsides, 44. Multiply my insides, they're both cubed roots, that's important. If these were not both cubed roots, you could not do this. You get negative 300. So now this one's a little tricky. A lot of kids are like, oh, it's 100. This is a cubed root, though. Think about your cubed roots. So 8 is 2 to the 3rd, 27 is 3, 64, 125. 125, nothing actually goes into 300. So the only thing I did to simplify is I don't like negatives inside a root. It bugs me, so I'm going to make my answer negative 44, the cubed root of 300. I like pulling that negative out because I think it's weird looking to have it inside. So that's it. We're done. All right, again, check that these are the same because we can't do this if those are different. All right, so I get the square root, the 5th root, JK, of 1024, x to the 11th. All right, so now grab your paper. What perfect 5th goes into 1024? 1024 is actually a perfect 5th. It's 4. 4 to the 5th is 1024. So we get 4 on the outside. And then the 5th root of x to the 11th, that's x to the 10 times x to the 1st, right? The 5th root of x to the 10th is x squared, right? 10 divided by 5. And then we just have the 5th root of x left over. So that's our answer. All right, same thing. You're distributing, though. All right, so distribute these out. So this guy gives me the cubed root of 10 plus 4 times the cubed root of 15. Can we simplify or add those together? We cannot. We are done. That is it. Right? 8 doesn't go into 10 or 15. You're done. 17 is a FOIL. Right? So first outer. So I get 35 minus 10, the 4th root of 8. And then here I get 21, the 4th root of 4, minus 6, the 4th root of 32. All right, now this one's a little tricky because we have to look, how can we simplify this? Any perfect fourths. Right? If you look at your chart, 2 to the 4th is 16, 3 to the 4th is 81. Right? So the only perfect fourth here would be the 16. So if you notice here, we have 16 and 2. So that gives us 35 minus 10, the fourth root of 8, 21, the fourth root of 4, minus 12, the fourth root of 2. Now, you cannot combine like terms. Now, a lot of kids stop at this point, but there's actually something else we can do. Remember, we talked about a couple times, the fourth root, right, x to the 1/4 is the same as x to the 1/2 to the 1/2. That's just a square root of a square root. A fourth root is the same as a double square root. So what is the square root of the square root of 4? Right? Look at that 4 right there. Square root of 4 is 2. So this can simplify to 21 root 2. Again, those are different radicand or different indices, so you can't do anything there. So I'm perfectly happy with this as your answer. It's still technically not simplified all the way, but I personally think this is the best answer. However, what we are technically supposed to do, and I kind of think it's dumb, is the fourth root of 8 is the fourth root of 4 times the fourth root of 2. The fourth root of 4 we just said is the same thing as a double square root, so it's the square root of 2 times the fourth root of 2. And that's actually the simplified answer. So what we're supposed to have is this, 10 root 2, fourth root of 2, plus 21 root 2, minus 12, the fourth root of 2. So this is technically the answer. I think that's weird looking. I prefer the green one as the answer. So I would accept either one of those. All right, last one, division. All right, see if you can get through these. All right, the cubed root of 810, x to the 5th. So these divide nicely, and we get the cubed root of 405, x to the 4th. What perfect cube goes into 405? Let's see, 405, I'm guessing it's 27. Yep, this is 27 and 15. The cubed root of 27 is 3. We can take an x to the, this is x cubed times x. And then we are left with our 15 and our leftover x. Pretty straightforward one. This one, again, we can't divide 3 into 128, so we're going to leave it as the fourth root of 128 x squared over the fourth root of 3. Now, when we rationalize the denominator, before we multiplied by itself. However, does this simplify? What does this give us? That gives us the fourth root of 9, right? There's still a root left over, so that wasn't helpful, right? What is 3 to the 4th? So that didn't help. 3 to the 4th is 81, right? So what we're actually looking for is we have that 4, the fourth root of 128x squared over the fourth root of 3. What we want is to multiply so that when we multiply this out, we end up with the fourth root of 81 so that that bottom one will go away. So what do we have to multiply by? We're going to multiply by the fourth root of 27 because 3 times 27 is 81. Also, what is 27? That's 3 to the 3rd. I have 3. I need a total of 4, so I need 3 more of them. Fourth root of 27. So these work out to that fourth root of 81, and then 128 times 27 is the fourth root of 3, 4, 5, 6 x squared. All right, so we know we have a 3 on the bottom. So now what perfect fourth goes into 3, 4, 5, 6? It's actually 16 and 216. 216 is 6 to the 3rd. So because it's only to the 3rd and we're doing a fourth root, you can't do anything there. So we end up with 2 the fourth root of 216 x squared. And again, we could actually break that x squared down into just a square root of x, but I don't feel like doing that. I'm going to fix this so it looks a little nicer. And that's it. All right, so there is a classwork and a homework. I'm limiting it. We're going to finish it next week when we review for our quiz. Have a fabulous day.